This is problem 30. It has 4 parts to it, I believe. The first part just asks us to find out the frequency of a light wave that possesses this much energy. And I just used Planck's constant and divided the energies by Planck's constant to find out the energy, or find out the frequency of the light wave. And the frequency comes out to be about 6.65 times 10 to the 14th hertz. In part B, they want to know what wavelength would be required to also possess this much energy. And I used the speed of light is equal to wavelength times frequency, divided the speed of light by the frequency, which I just calculated, and the wavelength comes out to be 4.5 times 10 to the minus 7 meters. What we just calculated, the wavelength, part 3 says, would a wavelength of 439 be sufficient? And since 435 has a smaller wavelength, so therefore the wavelengths would give you a higher frequency, so they'd have more energy. So 450 should work. And I calculate the energy of 450 by using the frequency, and the energy comes out to be 4.53 times 10 to the minus 19 joules. So when an electron is given off, the kinetic energy of the electron is equal to the difference in energy between the work function, how much energy it takes to remove an electron, and the energy of those photons. So I subtracted 4.41 times 10 to the minus 19, which is the work function, how much energy it takes to remove an electron, from the energy of this specific light wave having a wavelength of 450, and the difference is about 1.2 times 10 to the minus 20th joules. That's the energy of the kinetic energy of the electron as it leaves. And in the last part, they want to know how many electrons can be removed. And so in order to remove an electron, it has to be struck by a photon. So therefore, I just took 1 microjoule, found out how many joules that was, and each photon has this much energy. So I just guess I did a proportion. If this much energy is for 1 photon, then how many photons would you can create with this much energy? And I found it was 2.26 times 10 to the 12 photons, which means that you can make that many electrons leave.